So now we're going to look at something called polynomials, and we're going to be able to define basic polynomials and then how to add and subtract them. So a basic definition for a polynomial is a term is a number or a constant, a variable, or the product of a quotient of a number and one or more variables raised to a power. So these are terms. When I take those terms and I add them, subtract them together to get more terms, that's an algebraic expression. And the simplest algebraic expression is a polynomial. So the word poly meaning multiple, and so we have multiple terms. A polynomial is a singular term or a finite sum of terms in the form of ax to the n, where a is a real number we call the constant, x is the variable, and then the exponent n is going to be a whole number. So these are all examples of polynomials, and at the bottom, these are not polynomials because we need a whole number, meaning it has to be a positive exponent, and we also can't have them in the denominator because that is going to be a negative exponent as well. So the exponents have to be whole numbers, and they have to be positive. For each term of a polynomial, we have some different names. So if I look at 12x to the 9th, 12 is my coefficient, and the degree is 9 because that's the highest exponent. Here I have 3x. 3 is my coefficient, and I don't write an exponent, but it's implied to be 1. So negative 6 has a coefficient of negative 6, and we would say that it has a degree of 0 because there's no x value, which means an exponent of 0. And then you can keep going with this table. A polynomial that has only one variable x is called a polynomial in x, and the way we like to write them is in descending powers, meaning the highest exponent comes first and then it moves down from there. When we write it in descending powers, the leading term is the highest exponent, which is really convenient, and its coefficient is the leading coefficient. So we have special names for those first terms. So if I look at this polynomial and I want to write it in descending powers, I have to identify the leading term and the leading coefficient. So I'm looking at these terms. The highest exponent is 5. So I'm going to move that z to the 5th to the first term. Then I'm going to write it in descending powers, and I know that my largest exponent is 5, so my degree is 5. And z to the 5th is my leading term, and the coefficient is 1 because it's not written. Some polynomials with a specific number of terms have some special names. If there's 3 terms, it's a trinomial. If there's 2 terms, we call it a binomial. And if it's just 1 term, we call it a monomial. These are just some special classifications for polynomials that you might apply later on in the course. Although many polynomials only have one variable, it's not a rule. They can have as many variables as needed. What we do is we add the degree of the highest terms to get the greatest degree overall. So let's look what that looks like. Here, I have 5x cubed y to the 7th. I would have to add the degree of my x and add the degree of my y, so I have a total degree of 10. And then here, here's another example of a trinomial where I've got more than one variable. So here, the leading term, I'd have 9 plus 3 is 12. That's the highest one, so it's 12. Here, in this trinomial, the highest exponent is 5, and even though it belongs to the k and not to the z, the highest degree is going to be 5. So if you look at these, let's identify what they are and then look at the degree. So for the first one, that's going to be a binomial. It's going to be a degree of 7 because 4 plus 2 is 7. B is going to be a monomial. It has no variable, so it has a degree of 0. Let's look at adding and subtracting polynomials. Only terms that have the exact same variable raised to the exact same power can be combined. So we call this like terms. So let's look at these examples here. In part A, I color-coded them to identify what is like terms. If you look at 3x to the 4th and 9x to the 4th, they have the exact same variable with the exact same degree. And then same thing with the z's. So I'm just going to do 3 minus 9 is negative 6, and 2 plus 1 is 3. That's all it is. It's really helpful if you write these problems down in the lab and you color code them like I am. And B, again, I've color coded them and I've moved the order a little bit. I've put the T's next to the T's and the R's next to the R's. 3 minus 4 is negative 1. 4 minus 8 is negative 4. And there's my combined like terms. Same thing in Z. What I'm going to do here is box them in. So 5 plus 8 is 13. Then I have negative 3 and positive 12, and that's going to be 9 x cubed z squared. So it's just a different way than color coding. Some people don't like to color code. They like to draw boxes or circles, and you can also do that in part C. To find the sum of two polynomials, all you do is add them and combine your like terms. So let's look at an example. Here I want to add these two polynomials. I'm going to color code them by like terms. Since I'm adding, I can drop the parentheses off and move them next to each other. 5 plus 8. Negative 5 plus 8 is 3. 6 minus 12 is negative 6. So there's my added polynomial. Same thing here, it just looks different. I'm going to add my like terms. So here I have my like terms. So I have negative 6 plus 8 is 2. Positive 2 minus 2 is 0. And I have negative 1 plus 5r. So it's just writing it vertically instead of horizontally. There's no new math happening here. If I want to subtract polynomials, that's where I have to be careful because I'm going to have to distribute a negative value. So let's look at this example. Before I can drop the parentheses off, I have to change the sign of everybody in the second polynomial because that's how I distribute the negative. Now that I've done that, I can identify my like terms and combine them. 5 minus 2 is 3, and that's how you subtract polynomials. Here's an example of doing them vertically. Some students just like to show it this way in their work, but I would still need to change the sign of all the second ones because I'm distributing that negative through. Then I can do my like terms.